So let us consider the question which is given here. Construct a scale of 1:400 which can read up to 6 decameters. Also mark the distances of 42.8 and 3.9 meters on it. So from these, what are the data we know and what else we require, we will check it out. So first of all, in this, what the information we know? Representative factor is known to us. What is the representative factor for this problem? That is 1 divided by 400. And here read up to 6 decameters is given. Therefore maximum length is equal to 6 decameters. That is nothing but 60 meters. Good. So mark the distances of 42.8 and 33.9 meters on it. So from these, what is the least count we can able to expect? Sir, it is 42 meters is given. So 1 meter is the least. 3 meters is given. 1 meter is the least count. But point next element is also there. Therefore least count we can able to know indirectly as 0.1 meter. 0.1 meter here. So now first of all we have to find out which scale is more suitable for this particular problem. Which scale is suitable for this? So for that, let us consider capital N. So what is capital N? Maximum length by least count, that is equal to 60 meters divided by 0.1 meter, that is equal to 600. So here plane scale is not sufficient. We have to go ahead with either diagonal scale or Vernier scale. So in this case we are going to concentrate on Vernier scale. So once if it is a Vernier scale, what are the elements we require? So length of the scale is required, N1, N2 are required, and N3 also required for us. So for this particular problem, what is N1? That is maximum length by primary unit. How should I know this, sir? So we know that 6 decameters is the maximum length. So once if you write the units for this, millimeter, centimeter, decimeter, meter, decameter, hectometer and kilometer. So among these, 6 decameter is the maximum. So here 6 decameter will come here. So this is the maximum length. Therefore this particular decameter will become primary unit, meter will become secondary unit, decimeter will become Vernier unit. Now how much is N1 here? N1 is equal to maximum length is 6 decameters divided by 1 decameter is equal to 6. N2 is equal to primary unit divided by secondary unit. Primary unit is decameter divided by secondary unit is meter. 1 decameter is 10 meters divided by meter is equal to 10. What about N3? N3 is equal to secondary unit divided by Vernier unit. Secondary unit is meter divided by Vernier unit is decimeter. But we know 1 meter is equal to 10 decimeters divided by here decimeter. We are going to get 10. Fortunately, here if we observe, N2 is equal to N3, we got it. Therefore there is no need to struggle a lot for this. So how we have to solve this particular problem? First of all, we have to find out length of the scale, and the main scale should divide it into 6 parts, and subscale or secondary scale should divide it into 10 parts. Means the left part we should divide it into 10, and we have to take the length of n plus 1 or n minus 1 depending upon the problem, whether it is a backward Vernier or forward Vernier. Based on that, the Vernier scale length will be changes. So before that, we'll go ahead with what is the length of the scale. Length of the scale is equal to maximum length into representative factor. Maximum length is 60 meters. 6 decameter is nothing but 60 meters into 1 divided by 400. So that is equal to 60 into 100. 1 meter is nothing but 100 centimeters into 1 divided by 400. So here 2 zeros will get cancelled, and 4 ones are 4 15s are. Therefore, the length of the scale, we will get it as a 15 centimeters. So then what we have to do in this case, first of all, we have to construct a plane scale. Then we have to proceed. I am going to explain both forward vernier and backward vernier in it. So let us consider this is the scale, and for both the things we know the common elements. I am going to write at the bottom. So what are the common elements for both? Length of the scale and representative factor will be the same for both. So first one is a representative factor is equal to 1:400, and length of the scale is equal to 15 centimeters. In the examination, either top diagram or bottom diagram, only one is sufficient. But for your clarity, I am explaining both forward and backward vernier. Now, first of all, this is a 15 centimeters. We have to divide it into 5 parts. Each one we are going to get 2.5 centimeters. I am making it like this. So 1, 2, 3, 4, 5 and 6. So here also the same. 1, 2, 3, 4, 5. Now we have to give first, we have to start 0 here. 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So here it is going to be decameter. So here also I will write the same, decameter. So the primary unit is going to be so here decameter. So here 1 means 1 decameter, that is nothing but 10 meters. So now what I have to do, we have to divide the secondary scale into 10 equal parts. So because N2 is 10 for us, so if you observe here, N2 we have 10, the secondary unit we have to divide it into 10 parts. So we are going to divide the secondary scale into 10 parts by using acute angle line method. Now we are divided the vernier scale into subscale into 10 parts in both the cases. So what is the concept in vernier? We have to take n plus 1 units in case of backward vernier, n minus 1 units in case of forward vernier. So here we have to extend it little bit, and then we have to extend like this. But the length is most important here. How much length we have to take? N plus 1. So with the compass, how much length it is, you have to mark the same on the other side. So don't take rough estimated length. So here how much length it is, 1 unit length we have to take it, and from here we have to mark it, and that is related to the backward vernier. So once it is a forward vernier at 9, we have to extend it because n minus 1, because totally 10, n minus 1 means 9 we have to take it. So this is the vernier scale for backward vernier. This is the vernier scale for forward vernier. Now how many parts we have to make this, either backward or forward? How many parts we made for the subscale? The same number of parts, that is 10 parts. We'll try to make 10 parts on both the elements, and how we are going to get, just we'll observe. Now actually this is 10 meters. So what is the unit of it? It is meter. This is also meter. Now automatically the vernier unit will become decimeter. Vernier unit will become decimeter. Now here 11 meters is nothing but 110 decimeters. In this case it is going to become 9 decimeters. Sorry, 90 decimeters. 9 meters is nothing but 90 decimeters. Now here 110 we are divided into 10 equal parts. Therefore each one will become 11. 11 I am going to give alternatively 22, 33. Then it will become 44, 55. It is 66. Next one is 88. So this is okay, sir. What about here? In forward Vernier, this is 0, 9. This is going to be 18. 36 for your, it is not going to be that much visible, just you zoom it. Then it is going to be 54. Next one is 72. So it is in the 9th table we are going to have. So this is the way how we have to construct the Vernier scale. So this is okay, but how to mark the distances, that is most important. Now here, what are the distances we have to measure? One is 42.8 and another one is 39.3.9. So first one is 42.8. How we have to measure, we'll check it out. So 42.8 in case of forward Vernier, I will show it. 42.8 meters. What is meant by 42.8 meters? That is equal to 40 meters plus 2 meters plus 0.8 meters. That is equal to 4 decameters plus 2 meters plus 8 decimeters. So in the forward Vernier, if you observe 4 decameters, from here to here it is 4 decameters is okay. From here to here it is 2 meters, it is okay. But 8 decimeters, I don't have 8 in the decimeter. Then how we have to do this calculation? Sir, I don't have 8 decimeter, but I have 88 decimeters. Then how we have to do? Here the conversion is only the important. 42.8 meters. 8 decimeters is nothing but 0.8 meter. Therefore here 88 decimeters. 88 decimeters is nothing but 8.8 meters. So here whatever the last digit is there, I have to subtract that. Then what will happen? 0. It is going to be 4 and it is 34. So this is possible. So can I write 42.8 meters is equal to 34 plus 8.8 meters. It is correct. Now how we can able to do this? So here this is nothing but 30 meters, 4 meters plus 8.8 meters. That is equal to 3 decameter plus 4 meter plus 88 decimeters. All these are possible in case of this particular problem. How it is? So first of all, we'll go ahead with 88 decimeter. Where is the 88 decimeter? Here it is 88 decimeter is this. I'm going to extend it. So from here to here it is 88 decimeters is over. 4 meters I will do it later. It is 3 decameter. But how to mark? 0.4 meters. Now, so 3 decameters is up to this. But 4 meters, where from here? 0 to 4 you take it as radius. From 3 onwards you try to place the arc. So now here if you observe, so this is 3 decameters, this is going to be 4 meters. So we have to extend this particular line and we should write like this, and we have to give the arrowheads at both the places, and this particular length is going to be, just you write 42.8 meters. In bracket you write 3 decameters plus 4 meters plus 88 decimeters. This is the calculation you made here itself. Good. So what about the another calculations? So this is okay. And what about the other calculation? That is going to be 3.9 meters. How should we mark 3.9 here, sir? So how to mark 3.9? 3.9 meters. So for this, what is the calculation? Sir, last digit is 9. Therefore, we have to subtract 9.9, that is 99 decimeters. But we can't able to subtract it. So once if it is 9.9 only we have. But this value is less than the available decimeters. Then what I have to do? So 9.9 minus 3.9 is equal to 6.0. So how we can able to write 3.9 meters on it? That is equal to 9.9 meters minus 0.6 meters on it. So always addition is not going to be, sometimes subtraction is also comes into the picture. That is equal to, how much it is? 99 decimeters minus 0.6, sorry, it is not 0.6, it is 6 meters. 6 meters. So how we have to mark these? 99 minus 6. So where it is? So now if you observe, so from 0 to here it is 99. From 0 to this particular point, once I will show. 0 to here it is 99. Just all of you carefully observe, this is 99. But where is 6? So this is from here to here it is 6 meters. So we have to extend it. And this particular thing I am giving external dimensioning. External dimensioning from this gap. So this particular gap. So from here to here it is 99. From here to here it is 6. 99 minus 6. We are going to get it as 0.39. Just you write 0.39. Sorry, 3.9 meters. 3.9 meters is equal to 9.9 meters minus 6 meters is going to give 3.9 meters. This is the way how we have to mark the dimension in the backward vernier. Sir, what about in forward vernier? So how we have to make the calculation for forward vernier? What are the dimensions? Again we will check it out. 42.8 meters this is. How should we take it? So once if it is 42.8 meters, how we can able to take it? Last digit is 8. So this is also equal to 40 meters plus 2 meters plus 0.8 meter. That is nothing but 4 decameter plus 2 meter plus 8 decimeter. So here 8 decimeter is not there. 4 decameter and 2 meter we can able to mark it. Then how we have to do? In the ninth table where last digit is 8, 9, 18, 27, 36, 45, 54, 63, 72, 81. So here 8 is present here. Therefore what I have to do? So 42.8 means we have to subtract 1.8. So we can able to get 0, 41.0. So therefore 42.8 meters is equal to 41 plus 1.8 meter. That is equal to 40 meters plus 1 meter plus 1.8 meters. That is equal to 4 decameters, 1 meter plus 18 decimeter. So this one how we have to mark it on the back forward vernier. So where is 18 here? Where is 18 in this particular thing? Just we observe. 18 is going to be here. We are marking this. This is 18. Afterwards, how much we required? 18 decimeters. Then 4 decameter and 1 meter. This is 4 decameter. How should we get 1 meter? Take 0 to 1 as radius in the meter. Sir, this length is not that much possible to take it in the compass. Not a problem. So 10 to 1 you take it. This is going to be 9 meters. So from 5 you try to mark it. So automatically if it is 9 meters, this particular gap will become 1 meter. All the way how we have to do, you should be familiar. Sir, taking this small length with the compass is not possible. So from here to here 9 meters you take it, you can able to get here as 1. Therefore, how we can able to extend this? So 18 plus 40 plus 1. So totally it is going to be the required dimension, whatever we require. Arrowhead. And we have to give the dimension as here 42.8 meters is nothing but how much it is? 40 meters plus 1 meter plus 18 decimeter or 1.8 meter. This is the way how we have to do it. So another calculation, instead of 3.9 meters, we'll take one more dimension. So for forward vernier, instead of 3.9 meter, we are going to measure 2 point we are going to mark a distance of 5.2 meters on it. How to mark 5.2 meters on it? Just we'll check it out in the calculation. So we need to mark 5.2 meters. So where the last digit 2 is present in 72, but 52 minus 72 is not at all possible. Therefore I have to make 7.2 minus 5.2, that is equal to 2. So we can able to write 7.2 meters minus 2 meters is 5.7, that is 72 decimeters minus 2 meters is the answer. So how we have to mark this one? 72. So what is that? 72. Where is 72? This is going to be 72. But where is 2? 2 is here. 2 meters is this. So if we give the dimensions here, so this is the arrowhead here and this one is the another arrowhead. From here to here it is 72. From here to here it is 2. So we are subtracted 72 minus 20 is going to be 52. So we'll write this information as 5.2 meters is nothing but 7.2 meters, that is 72 decimeters. 72 decimeters minus 2 meters. This is the way how we have to measure the dimensions in case of both forward vernier as well as backward vernier we are come across. Most of the times in the exam, if they ask to construct the vernier without giving the information whether it is a forward or backward, then most of the students they will prefer backward vernier because the calculation wise it is easy and numbering is also easy, because as compared with 9th table we are most comfortable with 11th table. That is only the reason. So once if they specify which one we have to do it, we have to consider that particular thing only.